Today we're going to talk about adding, subtracting, and multiplying polynomials. So this task is about what we know to make conjectures about features of polynomial functions. So below are three polynomial functions, f of x, h of x, and m of x. We're going to use the polynomials above to explore each combination of functions, then identify the end behavior for the resulting function. So for the first one, what happens if we add f of x and h of x together? These are two linear functions. So if I add these together, I have x plus 1 plus h of x, which is negative 2x plus 2. So because this is a plus sign, I can just drop the parentheses and add like terms. So the x's are, of course, are like terms. So x minus 2x gives me negative x. And then the constants are like terms, so that's plus 3. So negative x plus 3, which of course is linear. So to remember to find the end behavior, you have to look at the lead term. The lead term is negative x, so the power and the leading coefficient. So this is degree 1 when it's not written, which is odd. And the leading coefficient is negative 1, which is negative. So remember, odd negative means the left end goes up and the right end goes down, which makes sense because this is linear. So this y-intercept here is 3. So if you think about your graph, here's 1, 2, 3. That's where you would cross the axis, and your graph would look something like this. So as x approaches negative infinity, so as we go towards negative infinity, your y values are going towards positive infinity. And as x approaches positive infinity, the y values are down here, so they go towards negative infinity. So remember, this was when we had up and then down for the end behavior. Go ahead and do the next one on your own. When you're done, on pause and check your work. So f of x plus m of x. So now we have x plus 1 plus, so linear plus a quadratic, because this is x squared minus 4. So if I add these together, so there is no like term with the x squared. There is no like term with the x, but 1 minus 4 is minus 3. So if I add a quadratic and a linear, I get a quadratic function. And so for this quadratic function, look at the power, because remember, when you're in standard form, it's the lead term. So this is my lead term. So the degree of this polynomial is 2, which is even. And the leading coefficient is 1, which is positive. So even positive, remember, both ends go up. And think about a quadratic that has a positive. That means you would have a U-shaped or parabola going up. So for this, as x approaches either positive or negative infinity, remember you can write it together, your y values would approach positive infinity. Looking at the next one, we have f of x minus h of x, and then 4 is m of x minus f of x. So go ahead and do these two on your own when you're done. On pause and check your work. So f of x, we have x plus 1 minus h of x, which is negative 2x plus 2. So keep in mind, remember, there's this 1 that goes right here as a placeholder, and we can go ahead and distribute that negative 1. So this one, you do have to be careful to make sure you put those in parentheses. So x plus 1 minus becomes plus, so 2x, and then negative 1 times 2 is minus 2, and then add your like terms. So this gives us 3x because of the x plus the 2x, and then 1 minus 2 is minus 1. So the degree of this is the lead term, which is a degree 1, so that's odd. And the leading coefficient is 3, which is positive. So odd positive means the right end's up and the left end is down. And if it helps you to think about a graph, so the y-intercept is negative 1 and the slope is going up 3 over 1. So your graph would look something like this. So as x approaches negative infinity, your y values go towards negative infinity. And as x approaches positive infinity, your y values go towards positive infinity. Now we're looking at m of x minus f of x. So m of x minus f of x, we have x squared minus 4 minus x plus 1. So remember that we have this 1 here, and it gets distributed because of that negative. So x squared minus 4 minus x minus 1. And then there are no like terms except for the constants with the negative 4 and the negative 1. So x squared minus x, and then that becomes minus 5. And so the degree of this polynomial is 2, which is even, and the leading coefficient is 1, which is positive. So again, just like the one above it, both ends go up. So as x approaches plus or minus infinity, your y values go towards positive infinity. And again, make sure you know those 4 scenarios without having to look at them, because that's important. So go ahead and do 5 and 6 on your own. When you're done, unpause and check your work. So for question number 5, now we are multiplying f of x, x plus 1, times h of x, which is negative 2x plus 2. So remember, to multiply, you need to FOIL. So we get x times negative 2x, which is negative 2x squared, and then x times 2, which is plus 2x. 1 times negative 2 is minus 2x, and 1 times 2 is plus 2. So then combine your like terms. Negative 2x squared plus 2x and negative 2x cancel out, so plus the 2. And so for this one, the degree is 2, which is even, and the leading coefficient now is negative 2, which is negative. So that means that both ends would go down, because this would be a quadratic function opening down. So as x approaches plus or minus infinity, your y values go towards negative infinity. Looking at this one, we have h of x times m of x. So h of x is negative 2x plus 2 times x squared minus 4. And then again, we're going to FOIL. So negative 2x times x squared is negative 2x cubed. Because remember, when you multiply something with the same base, you add the exponents. Negative 2x times negative 4 is plus 8x plus 2x squared minus 8. Combine your like terms, which we don't have. We just need to write this in standard form. So negative 2x cubed plus 2x squared plus 8x minus 8. That's our standard form. And so the degree from the leading term is degree 3. And the leading coefficient is negative 2. So this is odd negative. So odd negative means the left end is going up and the right end is going down. So as x approaches negative infinity, your y values are going to go towards positive infinity. And as x approaches positive infinity, your y values go towards negative infinity. All right, next page. Just as you can write a whole number as a product of its prime factors, you can write a polynomial as a product of its factors. The result is called factored form or intercept form. So for this one, this is a polynomial, and remember that polynomials don't have variables in the denominator or variables underneath radicals, whole number exponents, and no variable exponents. So for this one, it's in standard form because we have degree 3, 2, and 1. And if we want to write this in factored form, then the first thing we always want to look for is our greatest common factor. So the greatest common factor is what can go into all 3 of these terms. So they are even numbers, and the lowest even number we have is 2, so we know we're going to have a 2. And this has an x cubed, x squared, and x, so 2x is our GCF. So we're going to take that out first. When I divide each term by 2x, to take it out, I get x squared plus 5x plus 6. You could always distribute to check your work to see if it matches. So I'll write the GCF over here. So then for the next part, we're going to keep factoring. So this is a trinomial with 3 terms. We want factors of 6 that add up to 5. So we're going to set up our 2 binomial sets. We know that this is x plus and x plus because both signs are positive. So factors of 6 that add up to 5 would be 3 and 2. So this is my factored form. So write a polynomial in factored form. Then find the zeros. So to find the zeros, remember the zeros are when you're setting y equal to 0 and solving. So to find the zeros, you set your y equal to 0 and solve for x, because the zeros are really just the x intercepts of your graph. So if I set this equal to 0 and solve, that means if this factor is 0, then the whole thing is 0. 0 times anything is 0. If this binomial factor is 0, then 0 times anything is 0, and same thing here. So that's why we set each factor equal to 0 and solve. So here, divide by 2. 0 divided by 2 is 0. Here, subtract the 3. And here, subtract 2. So these are my solutions to my equation. So if you see zeros, the zeros are the same thing as saying x-intercepts. So find the x-intercepts, which is the same thing as saying find the solutions. And sometimes you might hear people say find the roots, because a lot of times when you solve, you're taking the square root. So zeros, x-intercept, solutions, or roots all mean the same thing if it says to find any of those. So if it said then find the solutions of the function, or find the x-intercepts, or find the roots of the functions, you're doing what we just did. So that means that x is equal to 0, -3, and -2. For the next part, we have 3x cubed minus 3x squared minus 36x. So again, find the GCF if it has one. So 3, 3, and 36 means that 3 can go into all of them, and also we have an x that's in common. So if I factor out the 3x from each term, we get 3x times, this would give me x squared minus x minus 12. So we want factors of -12 that add up to -1. So since this is negative and this is negative, that means you have to have a positive and a negative term. So factors of 12, 1 and 12 aren't going to work. If we do 3 and 4, that would work as long as our middle term is higher, that is negative, because this is negative here. So -4 and +3. So that's my factored form. So to find the solutions or the zeros, you want to set it equal to 0 and solve. So when I set 3x equal to 0 and x plus 3 equal to 0 and x minus 4 equal to 0, for the first one, divide both sides by 3. 0 divided by 3 is 0. Subtract the 3, add the 4. And so these are my roots of my equation, or the zeros of my equation. Looking at question number 9. See if you can do this one on your own. When you're done, you can unpause and we'll go ahead and check our work. So for this one, our greatest common factor, we have 3 and the 48. So 3 goes into both those terms, and x squared. So if I take out 3x squared from each term, I would get x squared minus 16. And so now this is 2 terms, unlike what we had up here, we had three terms, which is trinomial. So now we have a binomial. So remember, when you have a binomial, you look for your special patterns, and it has a minus. So is this the difference of two squares, or is this the difference of two cubes? Well, because this is squared, it's not going to be the cube one. And can we take the square root of 16? Yes. So the square root of x squared, remember, is x, and the square root of 16 is equal to 4. So that becomes 3x times, remember, for the difference of two cubes, you have one plus and one minus. So x plus 4 and x minus 4. So this is our factored form. So to find the solutions or the zeros, you set it equal to 0 and solve. So 3x equals 0, x plus 4 equals 0, and x minus 4 equals 0. So x equals 0, x equals -4, and x equals +4, because here you would subtract the 4, here you add the 4, and here you divide by the 3. Looking at question 10, so same thing, look for a GCF. It's already in our standard form. So for this one, we have 2, 7, and 30, so there's no numerical GCF, and also we only have x here and here, not here, so we don't have any variables we can take out. So because there's a number in front, we can use our slide and divide. So Swedish fish don't really swim, or if you want to use the factor by grouping that you learned last year, that's fine too. So 2 times -30 is the first thing I do for the slide, and multiply, and then rewrite. So x squared minus 7x minus 60. Then F stands for factor, so factors of -60 that add up to -7. So set up your binomial set. You know this is x and x. So one has to be plus and one has to be minus because the middle term is negative. If remember you don't know your factors of 60, which again, hopefully you can be able to write that down, but for now, if you need to use your calculator to help you, that's fine. So remember, you can do 60 divided by x to find your factors. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12. And so when I get to the 5 and the 12, I know that if the middle term is 5 and this is -12, then I know that's going to add up to -7. If you want here too, you could always put the negative in front if that helps you to then see that one should be negative, one should be positive. But again, hopefully you should be practicing without your calculator. So plus 5 and minus 12. Remember, D stands for divide, because if I FOIL this out right here, that does not equal this equation. So I have to take what I moved, which was the 2, and divide it back out by those numbers. And then R stands for reduce. So this doesn't reduce. So if it doesn't reduce, you swing that number in front. So 2x plus 5. 12 over 2 does reduce. So this becomes x minus 6. So this is my factored form. So if you were to FOIL that, you would get this equation here. Set it equal to 0 and solve. So 2x plus 5 equals 0 and x minus 6 equals 0. And for the swing in front, if it reduces, this is really over 1, so you don't need to put that 1 placeholder in front. I didn't say that before. So subtract the 5. 2x equals -5, divide by 2, and x equals -5 halves. Over here, add the 6, and x is equal to 6. So these are our solutions or our zeros of our equation. Now, why do we want to be able to factor these polynomials? What we're going to be getting into next is we're going to be using this factored form and the zeros to actually help us graph these functions. So later on, we're going to be able to take the zeros, because if you know the zeros are the x-intercepts, then on your graph, if we have 0, 0, because of the 0, -1, 2, 3, and -2. So if I know the x-intercepts, I can also find the end behavior. So the end behavior, you look at the lead term in standard form. So this is degree 3, which is odd. And the leading coefficient is 2, so odd positive. So remember, odd positive means the left end's down and the right end goes up. So we're going to learn to use this to make the left end down, the right end up, and then we're going to learn how to figure out what the middle of your graph is going to be doing. And so we'll talk about techniques later. For this graph, it actually would end up going like this. And so that's something that we're going to be leading into to do for all of our equations. So that's why it's important to know how to factor these polynomials and how to find the solutions and also how to find the end behavior, because it leads into how to graph these without using your graphing calculator, which is an important skill to learn, especially for upper level mathematics. So looking at these down here, so 11 and 12, well, these are not in standard form. These actually are already in factored form, so that's done. We just need to figure out what the solutions or the zeros of the equation are. So remember, you set this whole thing, your y equal to 0, and solve. So if I set each factor equal to 0 and solve, keep in mind when you have these factors, you don't really need to write the powers here, because to get rid of the powers, remember to undo that. If I have a power of 2, I'd take the square root of both sides. Here I have a power of 7, so I would take the 7th root of both sides. But if you take a square root or a 7th root or any root of 0, you always get 0. So really you don't need to write those powers when you're doing that step. You can leave them out, which you'll often see me doing. So here if I add the 6, I get x equals 6. Here I have x plus 4 equals 0. And again, so I don't need to write that power. So I get x equals negative 4 when I subtract the 4. Here x minus 1 equals 0. So x equals 1. So 6, negative 4, and 1 are our solutions. Over here, we have to set this equal to 0 and solve. So again, I don't really need to write the powers. If you want to, you can, but it's not necessary because again, the square root of 0 is just 0. So this is just x equals 0. So I'm just going to write x plus 3 equals 0 and x minus 8 equals 0. So that only works when you're in factored form, remember. So subtract 3, you get x equals negative 3. And then, sorry, that was 0. Over here, add the 8, x equals 8. So the next question says, which is not on your paper, but you want to write it down so you know. It says, how do you find the degree of a polynomial when it's in factored form? So those are the two that we just did for 11 and 12. So how we find it is different. You have to think about, well, if we're in standard form, you look at the leading term. So here you have to think about foiling it out. So when it's in factor form, you're going to think about foiling and combining your like terms to help you. So if you were to FOIL and combine your like terms to find the lead term, you would think about your powers, right? So here, this would be like x minus 6. This you have squared, so that means you have two of those. So x plus 4 times x plus 4. And this you would have 7 of. So x minus 1 times x minus 1 times x minus 1. So that's 3, 4, 5, 6, 7. So if I think about foiling this all out, nice thing about this is that the numbers or coefficients in front of all of my x's are 1, so 1 all the way across is just 1. So the lead, I'm going to write it here, lead term for this problem would be x times x times x times x times x. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the lead term would be x to the power of 10. And I found that because when you multiply something with the same base, you add the powers. So over here, same thing. If I were to write all this out, so x squared would be x times x, and then x plus 3 5 times. So 1, 2, 3, 4, and 5, and then x minus 8 4 times. So again, the nice thing about this one is all the numbers or coefficients in front are 1. If it wasn't 1, then you would just multiply those numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 x's. So that means if I did this one, the lead term would be x to the 11th. So that means to find the degree of a polynomial when it's in factored form, we're going to add the powers of the factors. So here, if we look at the powers, if it's not written, that's 1. So we did 1 plus 2 plus 7. So that gave us 10. For question 12, we have a power of 2, 5, and 4. So 2 plus 5 plus 4 equals 11. So that's a lot easier than having to write it all out. Can you write it all out? Of course, but it's a lot easier just to think about adding up those powers. And so that is how you would get your lead term to find your power. And then from there, you could find the end behavior by looking at your lead term, your degree, is it even or odd, and is the leading coefficient positive or negative? And that's it.